Hi, my name is Carlos Taminez, and I'm from Vertical Green in Spain. And we develop tools for small and medium farmers. Everybody talks about our focus is very community oriented. What we try and do is most of the food in the world is actually grown by small and medium-sized farmers. And most of the tools that are out there are for large-scale farming. And as you can see by a lot of the initiatives that have been in the world in vertical farming, everybody goes broke because the system doesn't work as a business model. Okay? So what we do at Vertical Green is we build small solutions for the farmers, right? We do global partnerships, and we aim to have a net zero goal. We want to make our products and our systems as sustainable as possible. The problem really is about centralized farming. The approach is really off, and it doesn't work for communities because centralized farming is very resource intensive, right? All our food has been commodified. What you find in shelves is what lasts the longer, right? We have a lot of monocropping, so we go to and buy basil, for example, and you only find one. There's like 45 types of it. And then it all relates to the carbon footprint of the systems, right? In addition to that, we have excessive waste, and that means a lot of the food that we grow ends up in the trash. So there are more realities that the market is completely broken, and it's really just because the value chain. This, for example, is the Horeca value chain, and what happens is here, you pay. So the farmer here gets paid very little money, right? The end user pays a lot of money, and this chain eats a lot of the value, and so the numbers don't work, right? And so why don't they work, right? They don't work because the system is centralized. The future is decentralizing the system. Really, it's creating many nodes, many productive nodes across the world, right? But that requires systems, that requires hardware. As you can see, right? You get to a point where you need the technological innovations, right, to be able to lead to the economic empowerment of communities. And this is where we come in. So we're developing all these tools, right, to all the gear, all the hardware, to be able to make this possible, to make this transition into a more sustainable future possible. So what do we do with it? These are core technology. It's climate optimized regenerative environments, and I want to explain why optimization. Because people talk about controlled environments, but controlling doesn't really work. Controlling is complex, right, to run. But if you optimize is very difficult to develop, but it's very easy to run, right? So essentially, we've created some structures that are made with polymers, right? Now that we're compliant, past compliant, we can be doing 23% bio-based or 61% bio-based. We have a multi-mechanism insulation. So, in insulation, you can put a different recipe. So you have a convective layer, a radiant layer, you have different types, and you can put outside different materials as well. So for hot weather, for example, we can put microscopic ceramic coatings. Whereas in a cold weather like this one, we would put an absorbing coating to heat up the structure. And so the structure already works dynamically, right? We have passive airflow. Once you go into a curvature, you start creating convection. So you eliminate the mold and all the toxic air inside. We have antibacterial systems. So basically, our systems are coated with nanoparticles of silver that are antibacterial in contact. So we can run our structure without pesticides. And they're also resistant because of the dome structure. The resistant, they have very high snow load properties, right? And then the advantage once you go into a curvature is that they're reflective. And so we use an 81% reflective material, which allows us to cut down the power, the light needed inside by about 30%, right? So you create less heat, you create less evaporation, you have natural convection, right? And then it's also very quiet. We're running, low as 19 decibels, right? Most people are running their structures at 70 decibels. So you don't really know the effects that this has on plant stress, right? Until you're able to measure it. But there's a significant change. And so what we do is we end up running at 64% less energy than controlled environment. And because you're running at 64% less energy draw, then you can do a lot of really cool stuff, right? And so what we've done is create an automated system. And why did we do this? I mean, look, we failed before. We failed miserably, okay? And we did the over-engineering stuff. And then we went back to this. So these are two mentors. This is Jody and Janice. They're two farmers from Pennsylvania. And once we failed, we realized that we needed farmers in the team. And so our engineers should work aligned to what the farmers want and not engineering overcoming what the farmers have learned. And so we shifted around the equation and we created systems that are completely different. Now they're bio-based, they're autonomic, they became polyvarietal, so we don't want to copying anymore, right? And they're very intuitive for farmers. They're intuitive with their core knowledge. So how do we run this inside? Well, we're able to make it because we're putting inside nice technologies. We're doing Phyto Boost. Phyto Boost is basically very similar to what people used to do in the 60s with the Emerson effect, right? Basically, you're running far red, you're running near infrared, far infrared, and as you can see, your photosynthetic rate just spikes, right? Now, people ask us, well, what do you do different lighting? Well, most lighting companies sell lights, so they're not going to tell you how to run it with less lights because they would sell less, right? But there are technologies. There's 3 companies out there that are doing sophisticated lighting using some of these, and you can see the performance. These are normal LEDs, and then you Phyto Boost. So you get to pick up on. You increase water retention, you better lighting penetration, you ensure continuous growth, right? And then you get about 30 to 40% more effective light on your plants, right? Now we've done it in different applications. So we have 3 versions. We have horizontal, vertical, and volumetric farming systems. In our system, the vertical application is our agrotunnels. They're like this. They can run leafy greens, herbs, edible flowers, and strawberries. And basically, the key, you've seen a lot of the systems in the market. Our system has 2 big advantages. One, that is polyvarietal. So basically, you can run a different plant on every port as long as they're pH compatible. And second, because we create an optimized environment, you can do cut and come again. And cut and come again is, if you're harvesting oranges, you don't kill the orange tree to harvest the oranges, right? Well, you do the same thing with herbs, right? When you used to be in grandma's farm, you go out, take out some leaves, and come back. Well, if you do the same, you cut in the seeding cycle, and so you get farmers at least 33 tons per year, right? And that makes a huge difference in their money, because if you're harvesting at least 33 times a year, your money's coming in 33 times a year. These guys out in the world, in Germany,